Yes, Assalamualaikum and good day. We continue again our discussion about the expert system topic. We have discussed last week until uh, the Bayesian rule expression, which we express it in terms of hypothesis and evidence. Okay, if you look here, based on the Bayesian rule, we have a probability of the evidence, probability of the hypothesis. We observe the hypothesis where the evidence occur. Okay? Then we have this expression. Okay? The conditional of the hypothesis being observed, evidence, hypothesis, probability, and so on. Okay? Where PH is the prior probability of hypothesis H being true. Okay, this is the probability of the hypothesis being true. Where E bar H is the probability that hypothesis H being true will result in evidence E. Okay. You observe hypothesis where the evidence B has occurred. It is what we mean. And then where the hypothesis is being false, probability of the hypothesis H being false. Okay, and then the probability of finding evidence H when the hypothesis is false. Okay, we continue. As you know that in the expert system, the probabilities required to solve a problem are provided by expert, the domain expert. Okay, where uh, where the knowledge engineer is the one that will convert into a probability to solve a problem, which the knowledge being given by the expert. So expert determine the prior probabilities. Okay? Prior probabilities. So for possible hypothesis PH and false hypothesis, and also conditional probability of evident E, evident if the hypothesis is true and the hypothesis is false. Okay. You observe the evidence, okay, either it is true, hypothesis is true, or hypothesis is false. Okay. This is actually the information provided by the expert. Okay, where user in the other way around, user provide information about the evidence observed and the expert system compute the conditional probability of hypothesis where evidence being provided. For H, or hypothesis in the light of the user supply evidence, probability or conditional probability of uh, hypothesis which provide by evidence, what we call it as a posterior probability of hypothesis H upon observing the evidence. Okay, there are two things that quite no info that we needed. Okay. First is from the expert, and then which part from the user. And based on the user is the one that interact with the expert system and provide the explanation or the assumption. Okay, let me go into uh, later on we go into example that can make more clear. Okay, we can take into account both, both and the hypothesis and evidence can be multiple. Okay, we can have multiple hypotheses. Okay, H, we can have until numbers of H, and also we can have multiple evidence where we can have a number of evidence. Okay, the hypothesis as well as the evidence should be mutually executive and exhaustive. Means that it cannot really the what they call the chance to occur. Okay, single evidence and multiple hypotheses we can see as below. Okay, this is the expression. We have a single evidence where we can have a numbers of hypotheses. Okay, so we can calculate. Okay, and then we have a multiple evidence and multiple hypotheses. Okay, this one we can refer back what is the purpose of individual probability that we need to calculate. But we are going into example that we can have some idea of how is the equation works. It is required to get the conditional probability of all possible combination of evidence for all hypotheses, and thus places an enormous burden on the expert. It's quite difficult, but if you can use the lesson, is that it gives you some idea of how you want to choose your reasoning inside the expert system. Okay, therefore, in expert system, conditional independence among different evidence assumed. Okay, we make assumption. Thus, instead of the unworkable equation. So, this is the one that we attain. Okay. Now, let now we consider some simple examples. The ranking potentially a true hypothesis. How we can rank uh, certain hypotheses which we consider is true. We want to accept which one. Okay, suppose an expert given this conditionally independent evidence. Okay, we can have three conditionally independent evidence which is not related between each other. We have evidence one, we have evidence two, and we have evidence three, where create mutually exclusive and exhaustive hypothesis one, hypothesis two, and hypothesis 3. Okay, we have three hypotheses and provide prior probability for this hypothesis. Uh, we can have this hypothesis actually is being given, okay, probability of hypothesis 1, probability of hypothesis 2, and probability of hypothesis 3, respectively. The expert also determine the conditional probability of observing each evidence for all possible hypotheses. Okay, this part also the expert can provide. Okay, probability, conditional probability of the evidence based on the way it observe the evidence for the possible hypothesis. For example, observe the evidence one and give all the possible hypothesis. What is a hypothesis? One hypothesis, two hypothesis, three. Observe evidence two, and then what is probability that we get hypothesis? Probability of hypothesis one, hypothesis two, hypothesis three. Yeah, so this is given by the expert. Here, this is the probability. The first one is probability of hypothesis. Probability of hypothesis. We have hypothesis one. The probability of hypothesis one. Probability of hypothesis two, and probability of hypothesis three. And then we observe evidence. Evidence one. And then what is the hypothesis one, hypothesis two, hypothesis three? Okay, same as we observe hypothesis two, and what is hypothesis 9, hypothesis 1, hypothesis 2, and hypothesis 3. The same as observe hypothesis 3, and what is hypothesis 1, hypothesis 2, and hypothesis 3. Okay, these are the conditional probability. You have to look carefully because I have a problem with the with recording using the PowerPoint since you cannot uh, after you go to the next page you cannot go to the previous page. So we need only to continue. You cannot go back to the previous page. So we look here, this is the probability of the hypothesis 1, 0.4, 0.35, and 0.25. Observe this one. Yeah, assume that we first observe the evidence 3. Okay. The expert system compute the posterior probability for all the hypotheses as okay, posterior probability. Okay, you require all the uh, terms. Here is the when we observe the probability of evidence 3, we are going to compare the probability of the hypothesis. So hypothesis 1 is 0.4, 0.25, and 0.25. Okay, this is the equation that we are going to use since we are going to observe hypothesis 3. Okay. So we hypotheses. So you are also evident 3. So evident 3 in the equation will not change. And then we look at all the hypotheses and we compare it with the one that we have. Okay, if we look back, if we observe evident 3, hypothesis 1 is 0.34. So without the hypothesis 1 probability is 0.4. So we have a decrease of it. And then for hypothesis 2 it's almost the same 0.34. Okay, in the previous, if you look at the previous table is 0.35. It's about the same. And hypothesis 3 is increased, okay? 0.32 from 0.25. Okay, after evidence E3 is observed, okay, believe in. Means that we believe in hypothesis H is decreased. This is it. 0.34 decrease from 0.4 and becomes equal to belief in hypothesis 2. Okay, hypothesis 2 is 0.35 is about equal. Belief in hypothesis 3, 0.32 is increased and even nearly reach belief in hypothesis 1 and hypothesis 2. It's about the same for hypothesis 1 and hypothesis 2. Okay, suppose now we observe the evident E1. So we have the posterior probability which we calculated as now we observe the probability E1. Okay, this is what we got. If you look here, probability of believing that hypothesis 1 is decreased, where probability of believing hypothesis 2 is increased, and hypothesis 3 is increased a bit only. Most likely 1. Okay. See, this is the highest one, the probability of hypothesis 2 to be believed. If you are developing the expert system, means that you are choosing this hypothesis. It means that you choose this hypothesis 2 to be the one that you will choose for reasoning. Okay, and then after observing evidence 2, okay, the final posterior probability of all hypotheses, calculate it, okay, and we have the result as for hypothesis 1, what is it? Is increase a bit from 0.4 to 0.45. Hypothesis 2, we believe we cannot believe it at all. Where hypothesis 3 is the one that is the highest in ranking. Okay? After we observe the hypothesis 2. although the initial ranking of hypothesis 1, 2, and 3, only hypothesis 1 and 3 which remain under consideration. Okay, 1 and 3. While hypothesis 2 may not, because it will be 0, considered at all. Okay, after all evidence, E1, E2, E3 will be observed.